Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic design for low power principles. So it is first divided. What do you mean by power? So power is nothing but P is equal to VI. V is nothing but voltage, I is nothing but current. So V is equal to IR, you can mention in the equation. So P is equal to I square into R. So here the power is divided into two. One is static power, another one is dynamic power. So first we will discuss about the dynamic power. So the outline of today's topic is power and energy, the differentiation, and next the dynamic power reduction, and following with the activity. Next topic we will discuss about the static power. So first, what do you mean by power? So power is nothing but that is P is equal to VI. In terms of IDD, we can discuss P of T is equal to IDD of T into VDD. So it is decided P of T is nothing but in terms of time it varies. So power is drawn from a voltage source. It is attached to the VDD, the power supply, and the energy is nothing but E is equal to integral part of 0 to t P of t into dt. So IDD of t into VDD of dt. So P of t is substituted. From this equation you can get the average power. P of average is equal to E by T. So the dynamic power reduction, it consider three main parameters. That is PD, the dynamic power, is divided into, that is defined into alpha into CVDD square F clock. F clock is nothing but clock frequency, and alpha is nothing but activity factor, and C is nothing but switching capacitance. So based on the switching capacitance, the dynamic power is varied. So if the chip is active, the dynamic power dissipation is high. Next, PD, the dynamic power is reduced while reducing the alpha, the activity factor, switching capacitance C, and VDD or F clock, clocking frequency. Next, the clocking gate, it's used to stop portions of the IC that are idle. If it is idle, the clock gate is stopping. So clock is nothing but the external triggering input. So whenever we are not using any IC related, for example, if you are not using the mobile phone, the clock gating is stopped the portions. Next, the device switching capacitance, it can be reduced by using the small transistors. That is internet switching capacitance, that can be reduced by proper floor planning. So floor planning is very important. Floor planning means that is it is divided which portions we need to plan the devices, that is transistors. Next, if the low power supply is used, then the power consumption is reduced. When more transistors are operated in velocity saturation region, performance will not be reduced because of the power supply. So low power supply, if it is used, means the performance will not be reduced because of its velocity saturation region. So the dynamic power, it is considered charge and discharging because it is used the capacitance. So capacitance function like a UPS. So it is charged, and when it is needed, it is discharged. So charging and leakage. Leakage means discharging. So one cycle involves rising and falling inputs, that are outputs. And rising outputs, it is charged Q is equal to CVDD. On falling output, the charge is dumped into ground. Ground is nothing but VDD. And next, it is repeated TF switching times, that is switching frequency times over an interval of time frequency. And next, we will discuss about the dynamic power. So B dynamic power, that is 1 by T, integral part of 0 to T, IDD of T into VDD of T. So VDD, it's constant term, that is 5 voltage, it comes across from the integral part. So VDD by T, so integral part of IDD of T into dt. So again you get the TF switching frequency CVDD. So you can get CVDD square F switching frequency. Next, the activity factor. So the clocking frequency F, that is switching frequency, is equal to activity factor into frequency. So if the activity factor alpha that is equal to 1, if the signal is clock. So alpha is equal to 1 by 2 means a signal switches 1 per cycle, and dynamic gates that is switch either 0 or 2 times per cycle. So alpha is equal to 1 by 2. Suppose if it is static gate, it is depends on the design, it is alpha is equal to 0.1. So short circuit current, when the transistors both at a time it is on, so it means short circuit occurs. So less than 10 percentage of dynamic power if rise or fall times are comparable for the input. So this is the example for the 200 M transistor chip, 220 mega logic transistors. The average with this 12 lambda, 180 means 4 lambda. So gate capacitance to F2 frequency, that is F by micrometer. Next, this is the dynamic example for the different logic, C logic and memory logic and the dynamic network. So following with the activity, we will discuss about the another, that is static power and also low power design in the next topic. Thank you.